All right, deep dive time. We're diving into metabolism today. No textbooks necessary, don't worry. We're talking about something that's happening inside you, like right now. As you listen to this, you ever wonder where you get the energy to, do anything?
It's really quite amazing when you think about it.
Yeah.
This process, we're talking glycolysis. It's how our bodies take glucose, basically sugar, and turn it into usable energy.
Yeah, it's like imagine, those 6 packs of energy drinks. Glucose is like that, all ready to go. And then glycolysis is our body unpacking each can using that energy. And for this deep dive, we're checking out this Ninja Nerd video, the one on YouTube, breaking down metabolism.
And they make a really good point right off the bat. Before we can even use that energy, the glucose has got to get into our cells, right? That's where these things called glucose transporters come in.
Okay, glucose transporters, what are those, like little doors?
Yeah, like specialized doors on our cells, specifically made of these proteins called GLUT proteins.
GLUT proteins, okay.
Yeah, but it's not just one type, though. It's like a whole family of these GLUT proteins, each one with its own, specialty depending on what cell it's on in the body.
Oh, interesting. So different cells have different doors. Why does that even matter?
Well, think about it. Your brain, super important, right? Constant need for glucose.
Big energy.
Huge. So it's got these GLUT1 transporters, really good at, consistently moving that glucose across the blood-brain barrier.
So like a security checkpoint.
Exactly. Like the brain's own little checkpoint.
Gotcha. So the brain has its own bouncers. What about other parts of the body?
Well, muscles, they need those quick bursts of energy, especially when you're working out, right? So they've got GLUT4 transporters, and these ones are super responsive to insulin.
Oh, insulin, the blood sugar one.
Exactly. So when we eat, blood sugar goes up.
And the insulin says, let's go.
Exactly. Open the doors. Those GLUT4 transporters, they open right up, let the glucose into the muscle cells. Boom, energy. It's why exercise is so good for blood sugar, by the way. Gets those transporters working.
Makes sense. Different transporters, different roles.
Yeah.
Like a customized glucose delivery system. So we've got the glucose inside the cell. Now what? What happens in glycolysis?
Now the real fun begins, right? We've got the 10 steps of glycolysis. It's how we get from glucose to actual usable energy. And it all starts with, well, let's just call it molecular manipulation.
Manipulation. Okay, that sounds kind of sus. What's happening?
Well, first, we got to make sure the glucose doesn't just wander off.
Right, it's got to stay put.
Exactly. There's this enzyme called hexokinase, sometimes glucokinase, depends on the cell. But anyway, it adds on this phosphate group to the glucose molecule.
Phosphate group, what's that do?
Think of it like a tag, or even like a lock,
Okay, I'm picturing it.
That little phosphate, it keeps the glucose from leaving the cell and lets everyone know, hey, this one's for glycolysis.
No sneaking out.
Exactly. So it's committed. And now we go through these 10 steps. Now don't worry about remembering every single molecule.
Oh, thank goodness.
The important part is just understanding the flow of energy.
10 steps though. Seems like a lot of work for one little glucose, right?
Well, it's a process, that's for sure.
Yeah.
But remember how we said it's like a dance? Glycolysis?
Yeah, the dance of energy.
Right. Well, some steps are more critical than others.
Like the stars of the show.
Exactly. One of these is controlled by this enzyme. It's called phosphofructokinase 1, PFK1.
Catchy. What's so special about PFK1?
This guy, he's the control freak of the pathway.
Control freak, huh? How so?
It's what we call the rate-limiting step. Basically, PFK1 controls how fast or slow the whole glycolysis thing goes.
Oh, so if PFK1 gets backed up,
everything slows down.
Makes sense. Our bodies are pretty efficient, right? Don't want to waste energy.
Exactly. We don't need tons of ATP just lying around if we don't need it. So PFK1, it makes sure glycolysis is, running at the right speed.
Our cells are so smart. It's like they have their own little managers or something.
Right. Okay, so another big player here, gotta mention glyceraldehyde 3-phosphate dehydrogenase.
Whoa, that's a mouthful.
Yeah, don't worry too much about the name. What it does is more important. This is where we really start seeing those energy drinks, the glucose, turning into actual energy the cell can use. This is where we get NADH.
NADH.
Yeah.
Another one of those letter things.
Basically, think of it like a shuttle bus.
A shuttle bus.
Yeah. And it's picking up high energy electrons. Those are the passengers.
Okay, so we're stripping energy from the glucose.
And putting it on the NADH.
Where's it go?
The electron transport chain. That's later, though. Big energy production happens there.
So NADH is like the shuttle to the big show. Okay, last step of glycolysis. What happens at the end of this whole thing?
The grand finale. This is where pyruvate kinase step in.
Pyruvate kinase, okay. Another enzyme.
It gives us that last push, a bit more ATP, and finally, we've got pyruvate.
Pyruvate. Isn't that doesn't it do something? I feel like that's not the end of the story.
You're right. Pyruvate, it's not done yet. It's got a big decision to make, actually. Depends on oxygen.
Ooh, oxygen. This is getting interesting. So what are the options here? What happens to our pyruvate?
Okay, so picture this. You just ran a marathon. That was glycolysis.
Intense.
If you've got plenty of oxygen, you're breathing fine, you can take the nice route to recovery.
The easy way.
Exactly. That's the aerobic path with oxygen.
Makes sense. So what's the other option? When you don't have enough oxygen?
Let's say you pushed it too hard in that marathon. Out of breath, muscles are burning.
The not so fun way.
Right. That's like the anaerobic path. Not ideal, but sometimes you gotta do what you gotta do.
So how does this relate to pyruvate?
Well, it all depends on if your cells have enough oxygen to keep the energy going strong. Plenty of oxygen, you go aerobic. Pyruvate goes to the mitochondria.
The mitochondria, powerhouse of the cell. But what if we're out of breath, like you said? Like pushing it at the gym?
Yeah, exactly. Like you're in the middle of that workout, muscles are aching, they need oxygen. That's when pyruvate, it takes that anaerobic detour.
The less scenic route. And what happens there?
Instead of the mitochondria, pyruvate turns into lactic acid. You know that feeling, that burn in your muscles?
Oh, yeah.
That's lactic acid.
So that's what that is.
Yeah.
I always thought it just meant I was out of shape or something.
Well, it can be a sign your muscles are working hard, yeah, using that anaerobic pathway, I mean. It's not bad, necessarily, just, not as efficient.
Right, makes sense. So aerobic route with oxygen to the mitochondria, anaerobic, no oxygen, lactic acid. Got it. But you were saying before about that enzyme, the one for lactic acid, what was it called?
Lactate dehydrogenase, LDH.
Right, LDH. You said it can tell us about what's going on in the body.
Yeah, like it's a signal. If your LDH levels are high, it could mean some of your tissues, they aren't getting enough oxygen, maybe there's an injury or, something like that.
So it's like a little warning sign for doctors. That's wild. It's amazing how we started with this little sugar molecule and look where we are.
Right. It's a whole process.
From transporters to, what was it, lactic acid.
And we're just scratching the surface, really.
I know, right? But okay, before we go too far down the rabbit hole, let's recap this glycolysis thing.
Sounds good.
Okay, so first, glucose gets into our cells. Those special GLUT proteins, like little doors.
Different doors for different cells.
Right. And then the 10 steps, that's where glucose turns into pyruvate, a little ATP along the way.
Can't forget the ATP.
And then NADH, our little shuttle bus.
Grabbing those electrons.
Headed for the electron transport chain. And then, depending on oxygen, pyruvate goes to the mitochondria.
Or lactic acid.
Right. It's a whole journey. This has been awesome. I feel like I actually understand what my body's doing now.
Me too. It really shows you how amazing our bodies are, like no matter what, they find a way to get us the energy we need.
Absolutely. From a little sugar to, well, everything we do. So until next time, everyone, keep those metabolic fires burning. And remember, every bite, every step, it's all part of the amazing dance of life.